It's the connections which are the most important aspect of what you are learning, of how to move from one area to another, to another, to another. And if you can't do it this way, you do it by graphs. If you can do it that way, you can solve by equations.
So if you look at them, you can see all of them are connected.
They are, absolutely. Everything you will be doing is connected. It is all connected. Your job is to make sure you fully understand how to move from one area to another and not get confused, okay? And that is the power of mathematics, because what mathematics does is it describes the real world, or tries to as best as it possibly can, okay? And the way it can do that is by comparing things that we can observe in real life and say, this matches this type of function in the quadratics, but I can prove it because the graph of it looks like this. Because you might be saying, when I throw a tennis ball, or when I push something into some water, I can launch into it like this, I can dive into the water like this, and I come up like this. You know, so you make these observations about how quadratic equations and graphs are linked. Okay, right. Let's move on to the next section. It is linked, but it's probably a requirement that actually I'm not sure we explained the significance of, but you'll see how it all fits in. Okay, so let's get rid of this. Let's open a new Blackboard up. Let's open. Oh, I've just moved to a new section. Where is it? Here we go. Lots of things there. Okay, let's make a start. Now, linked to quadratics, it is linked to what you've been doing, but we're going to be doing a special type of factorization. Okay, this is called, it's a special kind of factorization called the difference. There should be an N there. The difference of two squares. Right. What do we mean by this? What do we mean by the difference of two squares? Remember, we talked about how an equation for a quadratic, okay? The generalized formula could be ax squared plus bx plus c. What we're going to be looking at is, you could express this sort of a form like this, which would be a squared minus b squared, okay? And basically it would be something like this, okay? That equals a plus b. Don't get too confused by this. I'm going to show you exactly what it means. And a minus b. Can you see, if you've got something in this form, you can express it very quickly in this form. Very simple. And the only difference is the sign is different. There's a plus there and a minus there, but the values are exactly the same. The best way to understand this is by doing an example. Okay. First example we're going to do is something relatively straightforward. If somebody asks you to factorize this, how would you do that? Because there's no x term, there's no term on the other side, is there? So there's no x term here, there's only x squareds. So how do we do this? How do we do this? We've got to work out what we think is the let's try and express this as a series of squares. So what number is the square of 16? It's what's the square root of 16? First of all, what is it? This can be no square root.
Oh,
It's 4. So I could say this could be. I could write it as a series of squares. This is the same as saying 4x whole squared. Okay, does everyone understand what I just did there?
yes.
Okay, because if I just quickly, let me just bring that up. Because if I open that bracket, and remember what we said about squares, if I just take this up here, sorry, I'll take it down there actually, I might mess up. This just means 4x. Oh, why did that happen?
Wait, what?
Give me a second. I'm not sure why it did that. Okay, that's better. I'm not sure why it did that. So that just means 4x whole squared multiplied by 4x again. If I multiply the brackets out, the 4 times 4 is 16. X times x is x squared. So I can express it as this way. And remember, it's just a different way of showing this. Okay, that's what that means. What is the square root of 9?
So,
Yes, yes.
3.
you know, when you say the dots to 4x, what's in between it?
Oh, it's just a times. That's what it is. It's just a
Oh,
time. It's times. So if it's not clear, it's a times. Okay.
thank you.
Yeah. So somebody shouted out that it was 3, the square root. So essentially, I'm looking at this. So therefore, yes,
How do you get to the power of 2?
because I've just done the square root. So this is the
Okay.
original. That's just the original equation. But I can express this. This is exactly the same because 3 times 3. This just means 3 times 3. Okay. That's all that means. Okay, which is equal to 9.
Oh,
Okay. All I've done is add the indices. All the indices are adding up. Okay, that's all that means. Don't worry, we're going to go through lots of examples, so you will definitely get this. Okay. Now, as I know this, I can express this as what? I can express this very simply.
4 multiplied by 3.
No.
4x squared minus 3.
No, almost. So remember this general equation: 4x, okay, plus 3 do you see what we've done? So this relates to this generalization. Okay, so I've shown that this thing here, you know what, I'm going to draw it in a different color. So this is really important that we understand this, all of us. Okay, I'm going to just point it out in red. So this equation here is generalized by this, okay? And this equation, this representation is by this. So what we're trying to show, ladies and gentlemen, is that if I have something in this form, I can express it as this. And the way to get these particular numbers, A and B, is to work out the squares, okay, of them. Remember, do you remember the point that we raised here? The difference of 2 squares. Okay, not the squares geometrically, but the squares of the numbers. Okay, so that would be the answer. Okay, that would be the factorization that you have. Let's do another question because I got a feeling you guys just. We will definitely go on to more examples. All right. Okay. I'll keep that. I'll keep that example there. I'll keep that example there. I'll try not to move up too far so you can see it there. And we'll do example 2. All right. Right underneath. Have a look at it. So let's have a look at example 2. Example 2 is, yeah, let's take this one. Let's take this one. 5y squared probably not a great example, actually. I should have checked these, but it doesn't matter. It's meant to be a z. Okay. Z squared. So what can I do then? What can I do? What can I do? I can work out that this.
Sir,
Yes.
isn't 5 a factor of 80?
Absolutely. That's what we're going to do. Absolutely. You're jumping the gun, but you're absolutely right. Absolutely right. Yeah, absolutely. Okay. So that's what we're going to do. I think I've copied down the wrong one. Just give me a second, because I think this is a bad one to do, actually, because I think this is going to mess things up for you if I do it this way. Let's do another one. Let me just move.
Easy.
Here we go. Let's do some better ones. Let's do some better ones, because I think this is going to be a bit of a killer for you guys. Example 2.
Hard.
It is. And I don't want to give them too hard to you to discourage you. So let's do this. If I was going to express that, please, what do I do? What's the square of x? X squared. What's the square root of x squared? It's just x. It's just x whole squared, correct? That's all it is. Okay. How can I express 25 as a square? What number squared gives me 25?
5 squared.
Can you now see how I can rewrite this? How can I rewrite this now? X plus what number?
5.
And the second term is x.
Minus 5.
You're getting the hang of this. So can you see the difference of 2 squares? Okay, that's why I didn't want to give you the other one. The other one is horrible.
I don't get it.
Yeah. Which bit don't you get? Which bit don't you get? Yeah, don't just tell me which bit don't you get, because it's really important you understand this.
Example 2.
Yeah. Which bit do you stop understanding at? Which part do you stop understanding?
I just didn't get how you laid it out and stuff.
Okay. Have you done these before? Have you done
No.
Okay. So all we're going to do is all we're trying to show is how do we represent this as a difference of 2 squares. So the way we do it is to show this first number. Can I express it as a square? I can. Which is equal to x squared. Okay. I can also express 25 as a square. It'll be 5 times 5, which is equal to 5 squared. So therefore, this rule up here, remember we were looking at this rule, if I have a number or a series of numbers like this,